Dear friends, welcome to this video. So in this video, we will be talking about depth limited search, which is used in artificial intelligence. So depth limited search is also known as DLS, and you will find that this is quite similar to DFS but with certain conditions. So basically, we can consider a depth first search with a certain condition which we will be talking about in today's session, and that is actually equivalent to your depth limited search. We can consider this as similar to depth first search but with a predetermined limit. So since when we were doing depth first search, we saw that there was no limit to a certain depth. That means if I have a search space something like this, the search would go along a direction, along one direction until it reaches the last node, and if there are no further children which exist, it will backtrack and move to the next possible option which is given to it. However, here in depth limited search, we will be introducing a predetermined limit. That means that limit will be in terms of depth which will be associated with the search. That means up till this particular depth only the search will be possible along one direction. So this depth limited search can solve the drawbacks of infinite path in depth first search, which we observed that the depth first search it fails because it might be one of the condition might be if it gets stuck in an infinite loop. That means it does not actually know how many more nodes are there along one direction or along a particular depth. So in this algorithm, the node at the depth limit will treat as it has no successor nodes further. That means if I'm considering this depth limit, so let us consider that the depth limit associated with this with the DFS is equal to 2. That means up till level 2 only the search will be possible. So let's consider this as level 0. This might be level 1 and this will be level 2. So after this particular level 2, the search will not go beyond in the same direction, and it will consider that it does not have any other successor nodes, even though it might have, but it will consider that it does not have any other successor nodes apart from the whatever is there within the level 2. Okay, so depth first search is modified with a condition, which is we are associating a predetermined limit to the level along which the search would occur, and that particular condition based DFS is basically known as depth limited search. However, it helps to also, we have also discussed that it helps to overcome the problem of infinite path in DFS or infinite node in DFS. So this is slightly advanced than DFS because it will not get stuck in an infinite path. However, it has certain drawbacks. That means DLS can be terminated if any of the following two conditions occur. So what are those? The first condition, that the DLS might be a failure or it might be terminated, is when it achieves a standard failure value. By this, I mean to say that it indicates that the problem does not have any solution. So if the problem does not have any solution, then the standard failure value is attained and then the DLS would be terminated. And the second one is that when the search attains a cutoff failure value. That means it defines no solution for the problem within a given depth limit. So cutoff failure value basically pertains to the level or the limit of the level, and if within that particular limit we do not have the solution, then also the DLS can be terminated. So these are the two standard conditions under which the depth limited search can be terminated, and we have to understand that it has to be these two conditions needs to be checked on a regular basis, or in each iteration, at each iteration possible, so that we keep a check on the standard failure value and also the cutoff failure value. The next is we will be talking about advantages of DLS. First of all, and the primary advantage of DLS is there that it is memory efficient. It is memory efficient because it does not need to search the entire search space. It will search only up to a certain depth limit, that is a predetermined depth level. What can be the possible disadvantage? The disadvantage is similar to what traditional depth first search already has. First of all, it is incomplete because sometimes it might be so that if I have given the depth limit as equal to the level 2, but the goal might be at level 3 or level 4 or so on. So at that point of time, the solution could never be found. Hence, it is not considered as a complete solution. And the second one is that it is non-optimal. Non-optimal because DFS as a whole, since it is the foundation of DLS as well, it might be having multiple number of options or multiple number of solutions, which itself indicates that it is not a optimal solution, or it does not provide an optimal solution. There are always more than one solutions which are available in order to examine the route or examine the path. Now let us consider a small example. Suppose I have a tree something like this: S, A, B, C, D, E, F, G, then let's say I have I, J and H. Now let us consider that J is the goal node which we need to attain. Okay, so this is level 1, level 0, so level 1 and level 2, and we will also be introducing a depth limit as limit of the depth as equal to 2. So this is basically the goal node that we need to achieve. So what should be the output sequence or the search or the order of the search process or the search path? So initially the search would begin from the source node and then it will move along a certain path. So output sequence will initially have S here, followed by A, then C, because it will move across a level, and then from E, since it does not have any other nodes, but it would backtrack. So since E does not have any other node, so it would backtrack. However, in this particular condition, this is the traditional DFS I am talking about. So if we are considering the DLS, that is depth limited search, we have already associated the limit to be at level 2. That means the search will happen till level 2 only. So after moving from A to C, the search will not go from C to E. This search will not happen. Instead, it will simply be backtracking to the next parent node, and after that it will reach point D, that is node D, and after that it will be included in the output sequence. So now it will be backtracking. So this is already A is already in the output sequence. It will backtrack to S. So S is already in the output sequence. It will go to B and then to I, and from I it will not go to H because we have introduced a predetermined limit as level 2, so it will stop the search will stop in level 2 itself, and it will backtrack and reach J. So this is the search that will happen and the output sequence that would be generated using the depth limited search. This is because I have considered this particular direction initially. If I would have considered this particular direction, then the search would have happened in only just two iterations, that is from S, B and then to J. So this is how it should occur. I mean, this is how the search would take place because I have already associated the depth limit of the depth as the S2. So only up till level 2 the search will take place. So this is basically an advantage because it does not need to search the entire search space, but however it also becomes a disadvantage because if suppose within level 2 the goal would not have been there, then it would have been, the entire search would have been terminated, right? So it would have attained the current cutoff failure value. Okay, so this we have to remember while we are working with DLS, that if we are confident enough that within level 2 or level 3 my solution should be present, we can always associate a depth limit with it or a predetermined limit with it, so that the entire search space does not need to be searched, as well as we do not have to get stuck in any infinite loop or cyclic conditions. Okay, and lastly, the time complexity here also depends upon the depth limit, which is represented using branching factor to the power of limit. So L here gives the limit, while B stands for the branching factor that we have already been discussing. We can also calculate the space complexity, which will be impacted upon by the limits. So space complexity can be represented as B cross L, where L is the limit again. So this is all about depth limited search and the difference between the depth first search and the depth limited search. In order to address the disadvantage of depth first search, which gets stuck in an infinite path, depth limited search was introduced, and this search helps to find the solution in a more efficient manner, because if we have the slightest idea or if we have the solution within the levels of the predetermined limit, then we can easily find it with the minimum number of searches. So that is all for now. We will again talk further on uninformed searches in my next session. Thank you.